In this class, I will explain about two problems related to manometers and also pressure measurement. So the first problem is a review examination problem, January 2020. Figure is given like this. So sometimes they give the figure, sometimes they will not give the figure. If they don't give, you should be in a position to draw the figure and analyze. So this is the diagram he has given. There are two containers here. So placed side by side. In the first container you have oil and water, and the second container you have only water. So the specific gravity of the oil is 0.8, specific gravity of water, as you know, it is 1. And in the first container this oil is lying for a depth of 1 meter, and and the level of water, you see here, it is given as 1.5 meter up to this level. Please understand the elevations here. And he has given mercury in the manometer, whose specific gravity is 13.6. Now here he has attached two dial gauges here. Two dial gauges. In the first container, the dial gauge reading is 15 kN per meter square, which is positive gauge pressure. Second container, the dial gauge reading is 2 kN per meter square, which is vacuum pressure, which is taken as negative. So this is positive. It is in terms of gauge pressure. So negative pressure is called as the vacuum pressure. Now he has given the difference in elevation between the different liquids. Now the question here is, determine the manometer reading H. So what is the deflection of mercury level in the manometer? That is the vertical difference between the points A and B. That is the unknown here. H value we have to find out. Deflection in the mercury level. Now we have to analyze the problem by writing the gauge equation. I have explained in the earlier video about how to write the gauge equation. Now here I am going to use another method which is simpler than that. So first what we have to do here is, I will give the namings A and B for these mercury levels in the manometer. What I do is, I will calculate the pressure at A and pressure at B first. Pressure at A and pressure at B. PA and PB I will calculate. Here you can see that he has given air. Air is present here. So when they give the liquid as, when they give the fluid as air has got a very small value of specific gravity, very small. So that's why the pressure exerted by the portion of air can be neglected. That is one important concept. That means it means that whatever pressure is there here at the top of the container, same pressure will be there here at this level. That is the meaning of that, because the pressure exerted by this air can be neglected. Similarly here, whatever pressure is there here, same pressure exists here, because this air, whatever is present, that is the pressure exerted by that air can be neglected. That means the pressure at this level in this container is 15 kN per meter square. The pressure at this level in this container is minus 2 kN per meter square. Now if you want to calculate the pressure at A, now what we have to do is, I know the pressure here at this level as 15 kN per meter square. Then if I want the pressure at this level we have to add the pressure due to oil to this 15 kN per meter square. So 15 kN per meter square plus pressure of oil is given by P is equal to gamma H, hydrostatic pressure law. So here gamma of oil I have to take, H of oil I have to take. H of oil he has given 1 meter. Gamma of oil I can calculate by knowing S of oil. Similarly, if I want the pressure at A, I have to add once again the pressure exerted by this water column. So this water column, of course pressure exerted by this water column is this HW, whatever HW is there, multiplied by gamma W. So gamma into H for water we have to take. Now if you add all these three, you are going to get the pressure at the level A. Now here H0 is given as 1 meter, and this HW, whatever HW is there, this HW is, so it is nothing but this plus this. So this is nothing but H. So HW is this entire thing, 1.5 plus H, because water is present from here to here. So HW will be 1.5 plus H. Now I know the value of gamma W as 9.81 kilonewton per meter cube or 9010 Newton per meter cube. HW is 1.5 plus H, that is the height of water column. H naught is 1 meter, but gamma naught is gamma of oil, which is given by gamma W into S naught, SO, S of oil. That means when you multiply the specific gravity of oil by the specific weight of water, you are going to get the specific weight of that particular oil. Now, if you substitute that, gamma W is 9.81 kilonewton per meter cube into S naught is SO is given as 0.8, you are going to get 7.848 kilonewton per meter cube as the specific weight of oil. So now, once you substitute those values here, you can get the value of pressure at A. So pressure at A, all these values are gauge pressures. Please note that we are writing the pressures with respect to atmospheric pressure as datum. So PA is equal to 15. Since it is in kilonewton per meter square, that is kilopascal. Sometimes they give kPa. kPa means kilonewton per meter square because PA is Newton per meter square. 15 plus, see, because it is in kilonewton per meter square, I have taken the value of gamma in kilonewton per meter cube. You should be very careful. Suppose if this is in pascals, you have to take the value as in kilonewton per meter, Newton per meter square here. So since the value of pressure is given in kilonewton per meter square, I have taken gamma also in kilonewton per meter cube, but I have substituted. So 15 plus gamma naught is 7.848 into H of oil is 1 meter, see here, plus gamma W is 9.81 kilonewton per meter cube into HW is 1.5 plus H. Okay, now if you simplify this, you are going to get, so pressure at A as 37.563 plus 9.817. Now, what I do is, I will calculate the pressure at the level B dash now. Why I have chosen B dash is, you can observe here that point A and point B dash, they are at the same level. So pressures at the same level will be equal. So now what I can do here is, I can write the expression for B dash, pressure at B dash, and I can equate that to pressure at A because they are at the same level. Now instead of writing the pressure at B, I will write the pressure at B dash. Now, to write the pressure at B dash, I have to move from this end. That means from the second container, I have to start writing. Now, I will write the pressure at B dash as PB dash is equal to, I have to move from here. As I already told, the pressure here and here is same because air, pressure due to air can be neglected. So, it is negative here, here given maximum pressure. So, now PB dash is equal to minus 2 kilonewton per meter square plus pressure due to this water. Pressure due to this water from here to here. So here to here, pressure due to water will be gamma W into HW. So when you write, this is your HW. When you write this side. So it becomes gamma W into HW plus mercury is there from here to here. So it is having mercury is for height of H. So H into that means H means HHG. HHG is H here into gamma H. See here. So gamma into H is the expression for the intensity of pressure that I am using here. Now if you substitute the values minus 2 plus gamma W is has equal 9.81 into HW this side it is 2 meters plus gamma Hg is once again if you want gamma of mercury. So you have to multiply specific gravity of mercury with specific weight of water. 13.6 is specific gravity of mercury into 9.81 kilonewton per meter cube is specific weight of water into HHG is H itself. Now if you simplify this, you will get an expression for Pb dash as 17.62 plus 133.416 times H. Now as I already told, since A and B dash, they are at same level, so pressures at A and at B dash, they are equal. So I have to equate this PA to PB dash. Now if you equate and if you simplify, you will get H in meters of mercury, because this is H is expressed in deflection of mercury. So H is, you are getting 0.1613 meters of mercury, or it is 161.3 millimeters of mercury. So this is how you have to solve the problem when they give liquids in different containers. What I have done here is, I have taken the common level. So common level here I have chosen it as A and B dash. Normally the lower level of mercury is taken as the datum. So equate the pressures written at those 2 points. So you will get the unknown deflection of mercury. So this is one important question. So if you want the pressures at any level, you have to go on adding the pressures from the top point. So depending on the height and the specific gravity and specific weight, you can compute the pressure exerted by that particular liquid. And at different levels, you can always compute the pressure. So this is how we have to solve the problem. Now the second problem, it runs like this. A U-tube differential mercury manometer is connected between two pipes, X and Y. So there are two pipes here, pipe X and pipe Y. Here figure is not given. Please note that figure is not given. So you have to draw the figure. Pipe X contains carbon tetrachloride, CCl4 means carbon tetrachloride of specific gravity 1.6 under a pressure of 103 kilopascal. So here also he has given in kilopascal or kilonewton per meter square. Pressure in pipe X is 103 kPa. Pipe Y contains oil of specific gravity 0.8. So this is oil. In this pipe, oil is there 0.8 under a pressure of 172 kilopascal. So both are given in kilopascals. Pipe X is 2.5 meters above the center line of pipe Y. So after reading the entire problem, then only you have to start drawing. You have to start drawing the sketch. So now pipe X is above pipe B according to this. Find the deflection of mercury in the manometer. The mercury level in the limb connecting pipe X is in level with center of pipe Y. So these are the conditions. By reading the problem carefully, you can start drawing the sketch. So here, one point is pipe X is above pipe Y, and the difference in vertical elevation is 2.5 meters. That is one point. That is why I have taken center of pipe X and center of pipe Y. I have taken the points as A, and there are two different pipes, two different liquids are flowing. So the difference between these two is 2.5 meter. And another point he has given, and pressures he has given, PA and PB has given. PA is 103 kilopascal or 103 to 10 power 3 pascal or Newton per meter square. PB is 172 kilopascal or 172 to 10 power 3 Newton per meter square or pascal. So we have to find out the difference in the mercury level. So how to, one more thing he has given that the level, see here, the mercury level in the limb connecting pipe X. So that is, this is pipe X. So this is the limb of the manometer. So the limb connected to pipe X, mercury level is here at C. C is the mercury level. It is in level with center of pipe Y means, so this C and this B, they are at the same level. So after reading the problem carefully, you have to start drawing the sketch. Now the sketch is ready. So here you can see that since this pressure at B is more, we can take the mercury level lower at the limb which is connected to B. Now the unknown is H here. Now you can solve this problem by writing the gauge equation which I had explained in the earlier video in terms of meters of water. So gauge equation I will write in terms of pressure head of water or meters of water, because here you can see that there are three different liquids present in this system. One is carbon tetrachloride, another one is oil, another one is mercury. So all the three they have different specific gravity values. So to solve the problem, better you convert them into a single liquid, that is standard liquid, that is water. Now if you start writing the gauge equation, I have to start from one point, I have to move towards the last point, end point. So first point I will take it as A. I mark wherever there is a change in liquid, you have to mark those levels. So C, there is a change from from A to C, carbon tetrachloride is there. Specific gravity is 1.6. Difference between A to C is 2.5 meters, that is given. Then from C to D, you have mercury. Specific gravity is 13.6 for that mercury, and the difference in elevation is H, which is the unknown, which we have to find out. From D to B, you have oil, that is given. Specific gravity is 0.8, and once again the difference is H only here. D to B, difference is H only. Now by knowing this, now you can start writing the gauge equation. Start from this point A. In terms of water, if you want to write, PA is the pressure at A divided by gamma W, because we are writing in terms of water, pressure head of water. So P by gamma gives the pressure head in terms of water. So PA by gamma W is the pressure here. Then C point, next point is C. So at C is below the point A. If any point is below the previous point, pressure increases. That means you have to add plus sign. This I have explained in the earlier lecture also. Plus into this distance, vertical distance between those 2 points, 2.5, it should be in meters, multiplied by specific gravity of the liquid which is contained between those 2 points, that is carbon tetrachloride 1.6. So please note that this should be in meters, and this of course doesn't have any unit. Next point is D. D is also below C, so we have to add the pressure. Pressure will be more at D than the pressure at C. So plus. Now once again the difference between these two, C and D, vertical difference is H, multiplied by specific gravity of the liquid between C and D is mercury, which is 13.6. Now come to this point B. Point B is above D. So since it is above D, pressure at B is less than pressure at D, so minus sign. If the point is above, you have to take, next point is above, you have to take minus sign. If the next point is below, you have to take plus sign. So minus, once again this difference is H multiplied by specific gravity of oil, which is 0.8, which is given in the problem, and we have arrived at the point B now, that is equal to PV by gamma W. So now the values of PA and PV are given in the problem. So substitute the values and simplify. So if you substitute and simplify, you will get the equation like this. So I will now go on substituting. So PA is 103 into 10 cube. Of course, in Newton per meter square, into gamma W is 9810. Please note that if you are substituting this as in kPa, then you have to take in this as 9.81. If you are substituting 103 into 10 power 3, that is in pascals or Newton per meter square, then this should be 9810 Newton per meter cube. So plus 2.5 into 1.6, so that will be there. So you just try to simplify this, then plus 13.6 H minus 0.8 H means it becomes 12.8 H. This will be equal to 172 into 10 power 3 divided by 9810. Yeah. Now just solve this equation. Solving this equation, you get the value of H as 0.237 meter. So it is meters of mercury. Please note that it is meters of mercury, or you can write it as 237 millimeter of mercury. So this is the difference in the mercury level or deflection in the level of mercury in the manometer for the given problem. So the thing is, in this problem he has not given the sketch. He has given only wordings. So you should be in a position to draw the sketch. First step is drawing the sketch correctly. Mark all the elevation differences, specific gravities of the liquids, everything. Then second step, start writing the gauge equation in terms of meters of water or pressure head of water. So starting from the first point, move towards the end point. If the end point is exposed to open to atmosphere, then the pressure there is 0. Suppose if point B is open to atmosphere, this Pb value you have to take it as 0 as a gauge pressure. Then substitute the values which you know. So please keep it in mind, you should be very careful. If you are substituting the pressure values in kilopascal, then gamma W should be 9.81. If you are substituting pressure value in pascal or Newton per meter square, then gamma W should be 9810 Newton per meter cube. Here of course I have used in pascals. Then substitute all the values, whatever unknown h is there, you can get it by solving the equation.